So when we divide by multiples of 10, the decimal point moves to the left, the same number of decimal places as zeros in the multiple of 10. So for instance, if we start with the number 4.9, the decimal point is now going to move to the left one place because 10 just has the 1 0. So the answer becomes, I can do this one on here, moves that way one place, so the answer becomes 0.49, or you can write it as 0.49, it really doesn't matter. 12.5 divided by 100, so the decimal point needs to move 2 places to the left. So 12.5, decimal point moves 2 places, goes into that position, so the answer becomes 0.125. If you have a number like 0.043 divided by 1000, the 1000 has 3 decimal places, so the decimal point moves 1, 2, 3 places, so into that position. Fill any empty places with zeros, so the answer becomes 0.000, 3 zeros after the decimal point. Where are they? There they are. Oh, and that one too, so that's 443. If you wish to multiply one decimal number by another decimal number, you multiply the two numbers normally as though they were integers, ignoring the decimal point. Then you need to count the number of decimal places to the right-hand side of the decimal point in both numbers. So for instance, 1 place to the right-hand side of the decimal point in 2.7 and 2 places to the right-hand side of the decimal point in 3.12. So we have 3 decimal points that need to be accounted for in the answer. So then we give the final answer with the same number of decimal places to the right of the decimal point. So we've determined there are 3 decimal places to the right-hand side in both the numbers. So then we need to perform the multiplication as if the decimal numbers were ordinary numbers, so ignoring the decimal point. And beginning on the right-hand side, 7 times 2 is 14, carry the 1, 7 times 1 is 1, add 1 is 8, 7 times 3 is 21. A 0 in this position because it's the 2 is a 10, 2 times 2 is 4, 2 times 1 is 2, and 2 times 3 is 6. Add all of those values and we've got 8,424. Now we need to account for those 3 decimal places, which remember were this one, and this one. So that means our final answer is going to have the decimal point move from that position 3 places to the left. So the final answer becomes 8.424. Now if you have a think about it, the 2 numbers we multiplied were 3.12, which we can round off to 3, 2.7, which we can round off to 3. 3 times 3 is 9, which is fairly approximately the answer that we did get. So, and this is where I've got the estimate. The estimate was 3 times 3, and we can do that in our heads. 3 times 3 is 9. Moving on now to another one of these. Now be very careful, some of them are going to have negative numbers involved. For instance, the next one is a positive number multiplied by a negative number. There it is. And so our answer for this one is actually going to be negative. So if we now count the number of decimal points to the right hand side, we have 1, 2, 3, 4, 5. So let's just write that up here. We've got 5 decimal points which need to be accounted for in the answer. Then just rewrite it as if the decimal point didn't exist, so as integers, and perform your multiplication. So this one's a pretty easy one. Just multiplying through by 1 just repeats the original number. Multiplying through by 2 just doubles it. Wouldn't it be good if it was always this fast? And then adding the 2 rows. So you can see we've got quite a few digits here in the answer, but now we need to account for the 5 decimal points in the original 2 numbers. So we've got to move our decimal place back 1, 2, 3, 4, 5. So the final answer for this one is 2.25876. We've got the 5 decimal places in the answer that we needed to have. But the one thing we need to remember, of course, is that one of the numbers was negative, so the answer for this one is negative. To make an estimate of the answer, we could have rounded off the first number to 100. So let's write that down here, 100. And then we had to multiply by 0.021, which is rounded off 2 over 100. The 100s will cancel out, and the estimate of your answer is 2, which is pretty close to the answer that we did get, or approximates the answer that we did get.